Welcome to the fifth session of this generative AI series. Since the last couple of sessions, we've been leveling up each time that we've met, starting from prompts to we explored the workflows, we explored agents last time, but all of this has been through a no-code platform called n8n, which we heavily used the last session. This time, we are taking a step further, and we are going to build agents the way we actually build production-ready AI applications, using a code-first approach. So this time we'll be using Google ADK, and we'll also be exploring different types of agents that can come into play depending on the use case, and we will walk you through how you can work on architecting these types of agents, what kind of agent you should use when. So hopefully this will be a very meaningful session. Joining us today to conduct these sessions, we have two very capable engineers at Jeavio. Shunal, who's a key tech lead leading one of our core AI products. As Jeavio, he's been very driven in this space and has been contributing consistently to take the AI initiatives forward. And joining him is Soumya. He has joined us probably a half a year ago, but in such a short time, he has ramped up really fast and has gained really good experience, working knowledge in working on healthcare domain AI products. So both of them have put in tremendous effort to curate a lot of interesting demonstrations for you guys. Hope you guys can make the most of it. Thank you so much.
Thank you, Vrunda. Can you guys hear me clear? Yeah. Okay, cool. So thank you so much for joining. Today we are gonna do the bit of deep dive into the fifth AI session. That is all about leveling up your AI game with Google Agent Development Kit. So this is the session agenda. We are gonna do a bit of recap of what we did in the last session. Then we'll do a bit of understanding of what is the building the AI agent with no code and code first framework. We'll then do the deep dive into the Google ADK concepts. We'll see the different concepts of implementing sequential agents, loop agents, parallel agents, and custom agents. And then we'll go through few examples that we have already implemented for you. So this is the site link, PPT link. If anybody is having trouble reading the content, please scan this one so you'll be able to see the PPT live. Jen? Okay, so before we begin, we hardly remember what was covered in the last AI session, so we'll just do a bit of recap of what we discussed. So we talked about AI agents in the last session. AI agents is nothing but an LLM running in the loop. It continuously observes the environment, get the current context and state from the environment. Then it reasons in solving the problem, and then it will repeat this action, take some action using tools until the problem is resolved and the task is completed. We can also drive the agent behavior with the system prompt. So there are three main things inside the AI agents. One is memory, another is tools, and the third one is the guardrail. So we have basically three types of memory into the agents. We have short-term, long-term, and semantic memory. Short-term memory is useful for the current session, like whatever interaction we are doing with the AI agents, that holds into the short-term memory. Long-term memory holds the past conversation. It also holds the user preference, historical context. So whenever you want to recollect anything that you have discussed few months ago or few weeks ago, you can reference that from the long-term memory. Then we have semantic memory. Semantic memory is the external knowledge that we integrate with the AI system, AI agents. So it's a RAG system that you can integrate that will act as an external knowledge for your AI agents. Then we have tools. Agents without tools is nothing, just a simple chatbot. So let's say if you give additional hands to your agent, you can integrate different tools. With the help of tools, agents can do the web search. It can also call any other services. It can perform API requests for you. It can also execute code snippets. So that will increase the capability of your AI agents. Then we have guardrails. We of course want to drive the agents in a safe environment, like we want to restrict what it can do, and we also want to restrict it into giving the biased and irrelevant outputs. So that can be achieved with guardrails. Now we will look into the different types of building AI agents. So we have two main types of implementing AI agents. The one that we have seen so far using n8n, and the one that we are going to do a bit of deep dive today into with the code first framework. So there are a few differences in terms of implementing AI agents with either of these things. With the n8n, you can implement anything with rapid prototyping because everything is available in a drag and drop fashion. Whereas in case of code first framework, you should have a good programming skills in order to write everything from scratch. And since everything is available readily in n8n, you can just drag and drop, and there are very limited customization options available. And as a result, you can eventually end up implementing simple workflow. And with the case of code first framework, you get a lot of customization because you are driving everything from you are writing everything from scratch, and you get a lot of control on what you want to write, and you end up implementing even complex workflows using code first framework. Further differences are around debugging, cost, and the security. So since everything is very easy in n8n, you can just easily identify the data flow, and you can debug it. But for the code first framework, you have different tools available already for the debugging purposes, and you need coding experience as well. The cost for the hosting of n8n agent depends on the subscription that you take, whereas in case of code first, it goes to the resources that you consume. There are no licensing fees available for the code first framework. Then in terms of security, n8n, it goes for the user configuration, but in case of code first framework, you have standard software development practices available for securing your AI agents. So these are the few code first AI agent framework available in the market right now that you can use to implement AI agents. We have LangGraph, we have Crew AI, Google Agent Development Kit, we have AutoGen, and we also have OpenAI Agents SDK. So today we are going to do the bit of deep dive into the Google Agent Development Kit. So of course, when we choose one framework over the other, the obvious question is like, why Google ADK? So there are few fundamental differences that make Google ADK as an ideal choice. Like it has fully integrated agent runtime available. Like you don't need to configure anything if you want to run your agent. The event-driven orchestration is easier to implement in Google ADK. It has also built-in memory available that you can leverage. The multi-agent workflow is very easier to integrate over here. And you can easily run this agents into the browser without doing any additional configuration. And that's why they are simple enough to teach and implement prototype version. And for the production ready also, you can use them for the production application and productionize your AI agents. So now that we have chosen our approach, I'll request Soumya to give you a detailed walkthrough of the different Google ADK concepts, and we'll understand them in one by one. Over to you, Soumya.
Yeah, thank you, Kunal, for a quick recap of the previous session. Let's dive deep into Google ADK. So agents are the most fundamental part which are designed to carry out some specific tasks. And in Google ADK, there are three types of such agents. One of them is LLM agents. These are the thinking agents. They use the power of LLM to understand, first of all, the user language, what user is actually talking about. Then we'll do some reasoning and take a decision. And for LLM agents, the control flow is basically very dynamic and non-deterministic. Second comes workflow agents, where they don't think, they just orchestrate, and their execution flow is very deterministic and predefined. And there are three types of workflow agents. One is sequential. As the name itself says, it is related to sequencing. So there will be one agent, then comes another, and the pipeline continues till it finishes. Second comes parallel execution, where many of the agents work in parallel, and then some task happens. And last comes loop execution, where it is basically used when there is iterative iterative improvement needed. So it will go in loop and loop other when till the certain condition is met. And lastly, we have custom agents. This provides maximum flexibility. So you can create your own agent, which is inherited from a base agent that Google ADK provides to you. And you can write your own orchestration logic. Now for the next set of slides, we will be iteratively building out this Book My Show example, thereby also understanding what LLM agents are and what ecosystem does it comes with. Now, before we move on, let's take a step back and look at what we are aiming to achieve. So we are going to build an intelligent multi-agent conversational system where user can do three things. One is movie discovery. So user can query and search about movies by title, genre, and also he or she can view the top rated movies. Second is showtime information, where user can find when and where movies are playing across all locations and theaters. And lastly, and the most important functionality is seat booking, where user can check the seat availability, view the pricing of the seat, and then book seats for chosen showtimes. Now, coming to the coding part. So when you are coding LLM agents, there are the four most important attributes that you have to initialize while making an LLM agent. One of them is name. So let's say there are three agents in your multi-agent framework. So each agent should have a unique identifier name. Now, why it should be unique? Because for agent A, let's say my name is movie agent. Now that movie agent name will be used in the other prompts as well for internal routing. So it should be unique. Second comes description, which is a concise summary of what the agent is specialized to do. And the beauty of this parameter will become more evident when I will show you the final version of the example. Third, obviously, you need the brain, right? So we have LLM model. So you can attach LLM model to the agent. And lastly, there is an operating manual, which we know as prompt, that needs to be passed for the LLM agents. Now let me go over to the code base. So here is my Book My Show example, which is divided into different versions that we will be going out iteratively. So before we dive into the code, first of all, it's important for us to know the dependencies of your project. So if I move over to requirements.txt, you would guess first most library that we have to install is Google ADK. Second comes .env. This library is needed because we will be fetching the env variables that you set in your .env file. Okay, zoom. So second is .env library. So this library is needed because there will be certain your credentials that will be saving in .env file, and in your code base we will be extracting those env variables using .env. And as you will see in the last version of this example, that all of our data is stored in Supabase database. It's not local to your machine. So in order to query the data from the database, in order to do some update operations, you will need Supabase library to connect your local application with Supabase. Now let me go over for the part one of the example. As you can see, there is agent.py. Here you can see I have created a movie agent, which is an LLM agent. And from where am I importing LLM agent? From the Google ADK library. Now these are the four attributes that we talked over the slide. One is the name, which I have given movie agent. Second is the model, which I am fetching from the env file. And for that purpose, let me also show you the env file. So here I have 4 to 5 credentials entered over here. One is the model. For purposes, I am using Gemini 2.0 Flash. Also, you have to specify your API key over here. And for Supabase also, there are 2 credentials that you need to enter. So I have given model Gemini 2.0 Flash. Then also I have provided the prompt that we will look. And then comes the description, a short and sweet description about what the model does for you. It tells me it provides movie information based on title, genre, and rating. Now let me also go through the prompt of the movie agent, and it's just a simple prompt. As you can see, you are a movie agent, a friendly, knowledgeable movie expert who loves talking about films. And there are extra 2 to 3 lines added, which tells the agent how actually you should respond to the user. Now, in order to run this particular application, as Krunal mentioned, that why Google ADK? One of the foremost point that he mentioned was it provides your web UI to check whether your system is working fine or not. And that particular tool is ADK Web. So the command is ADK web, and then you can specify at which port do you want to run your server. For me, I have mentioned 8001, and when you will enter this command, you will see that the server has started running. Now let me move over to the web UI. So this is the UI that Google ADK supports. And let me click to part 1. And here is the chat interface where you can just test whether your agents are working fine or not. And just, yeah, tell me. I'm a DC fan. Tell me about Joker. So what you will see here is that when I asked the query, tell me about Joker, then it replied with some data. Now, actually, you can also see that there is one event triggered, and you can view the traceability over here. When I click over here, you will see that first of all, when I entered the query, it invoked the movie agent. And when it invoked it, it just made one LLM call, and whatever output that LLM give to you, it passed back to the user. So an agent with just the prompt, with no tools, with no callbacks, with no guardrails, is just like an LLM call. There is no power of agent in that. Yeah. So many of you will think that the ADK itself is built by Google, so it will only support Gemini models. But that's not the case. You can use any models, and the ADK is model agnostic. So it does not care which model is powering your agent. In order to use other models than Gemini, there is one such library called Light LLM. So you can just pip install Light LLM, and you will get access to that library. And you can see over here that previously in the code base, there was model equal to just a string Gemini 2.0 flash. But in order to use, let's say I want to use GPT 4.1, then what I will do here is, I just create a Light LLM instance and will pass two key attributes. One is the model that I will mention GPT 4.1, and for the API key, I will pass the OpenAI API key, and that will do your job. Tools. Okay, so tools provide a bit of extra functionality to the agent. So till now, you see that agent was only able to converse with the user. But tools add the functionality to it facilitates the agent that it can do various tasks, like querying the database, calling some API, doing third-party integrations. So how the process works is, first of all, there comes user intent detection. So agent tries to know what user is actually asking, whether he or she is initiating a query or a task. Once a user intent detection is done, it will go to AI agent processing step. So here, AI agent knows what user wants. Now it strategizes the plan about how to execute it. So let's say for an agent, I have attached 3 tools to that agent. Then can be many cases, like from the 3 tools, there is only one tool that does the job and not all the 3 are needed. So it will select which tool to invoke that will do the job for you. And once the tool has been selected, it will be called and executed. And whatever output the tool gave to the LLM, it will just do some polishing to the output and return the final output to the user. So for this, we have part 2, tool. As you can see here, that these 4 things remains the same. It's just a carry forward of what we had in part 1. And extra attribute that we have added is tools. And there are 3 functions that are attached to this agent. And we can just move over to tool.py to view them. And for the sake of example, we have just provided a static list of movies, which is a list of movie objects. And for each object, we have 3 key parameters. One is the name of the movie, then the genre, and then rating. We have 10 to 12 such movies here. And this is a tool. Tool is nothing but a function that does some task. So let me iterate through one of those tools to give you a better understanding of what exactly it does. So I have defined one tool here, get movie details by title. And there is one argument that needs to be passed, which is title, and that is string. What this code does is, let's say I'm talking about Joker. Then what it does is, it will search whether Joker is here or not. Here it will find that there is Joker. So what it will do is, this particular dictionary will be written back to the prompt, and prompt can do some polishing there. If I enter Hera Fairy, which is obviously not here, then it will return this string that no movie found with title Hera Fairy. Now, only adding tools here don't do the magic for you. You also need to mention in the prompt as well. So along with some extra English, there is one important section that is mentioned in the prompt are available tools. So for each tool, you have to add 2 to 3 things about what the tool actually is, how to call it, then when actually you have to call it, and what kind of response will it return. So let me go through one of them. There is one tool which is get movie details by title and pass it the title, and when should the agent invoke this tool. So when user want to fetch the title, rating and genre for a specific movie, then use this tool to get the data. Now running this part 2 tool, and let's say uh, tell me. Then you will see here that when I asked tell me about Joker, then it made a tool call which is get movie details by title. And it called this by passing an attribute Joker, the string attribute that we need to pass. And after this tool returned something, there was a statement made that Joker is a drama movie rated 8.4. Now for that, let me show you the execution flow. So as you see here, that first of all, we are invoking the movie agent. Now you will see that movie agent is making 2 LLM calls, not one. Now you might be surprised that for one query, why are we making 2 LLM calls and not one? The reason is pretty simple, that first LLM call actually decides which tool to call. Once it decides, the tool is being executed. And once the tool is being executed, tool will return the output and some polishing will be done by this LLM and the final output is presented to the user. Callbacks. Think of callbacks as hooks into by hooking into the different parts of your or stages of your life cycle. There are many use cases of callbacks, but just naming a few. One of which is safety guardrails. This ensures operations stay within boundaries, enhancing safety. So there are 2 types of safety guardrails. One is input guardrail and another is output guardrail. One is input guardrail and one is output guardrail. What they do for you is, let's say user has entered some query, tell me about Joker, and comes the agent that receives the query. Now input guardrail lies in between. It will check whether this particular query falls into the movie agent domain or not, because user is not constrained to enter something that is inside the domain. He can enter anything. What's the weather today? Who is the PM of India, right? So there comes input guardrail. It will check whether the user query is legit or not. If it is legit, then it will pass that query to the agent. Otherwise, the guardrail will trigger and agent execution will not take place. Similarly, we have output guardrail. So in the reverse way, once the agent completes execution, it will return the output to the user. And between that, there comes output guardrail. Output guardrail will check whether the agent output is satisfying, is legit, is up to the mark or not. If it does, then the output will be sent to the user. Otherwise, output guardrail will be triggered. Then comes validation processes. It confirms data accuracy, improving reliability. So any validations that you need to do for the inflow and outflow of the data, then also you can use callbacks for. Callback can also be used for doing prompt enrichment. So by passing some extra context or doing structuring of the information, then also use callbacks. You can also use for agent lifecycle integration for streamlining processes for the decision cycle. And lastly, and the foremost and the most simple thing is if you want to log something. So can be many callbacks in your system, and you can do simple logging to check whether everything is working fine or not. There are 3 types of callbacks. One is agent callbacks. This can be used if you want to hook into the agent decision cycle. Second come tool callbacks. For this also you have 2 flavors. One is before tool callback and another is after tool callback. What before tool callback can do for you is, when a tool is being executed, you can check for the arguments whether the arguments that are being passed to the tool is perfect or not. And after tool callback can check for the results that are delivered by the tool. Similarly, model callbacks. So what I was talking about guardrails, input guardrail and output guardrail. So that can be used here in model callback section. So before model callback can act as an input guardrail for you, and after model callback can act as a output guardrail for you. Yeah, so for part 3 of this application, Here is my movie agent. All these 5 things remains the same. And I have added 6 functions to 6 different parameters of light LLM of LLM agent. So there is before agent callback, after agent callback, then before model callback, after model callback, and similarly for the tool. These functions are pretty simple, nothing fancy here. Let me go to callback.py. I'm just logging. So I have created a function and I'm doing nothing over here. I'm just printing whether that function was called or not. The only thing that I'm implementing over here is input guardrail, and that you can see here before model callback. Now in this function definition, what actually happens is, let me explain you the code. This part of your code actually fetches the user query, what the user has asked for. So in this variable, you have the user query. Then I'm invoking a guardrail prompt with and passing that user query. Now let me show you the prompt, how the prompt is structured. The prompt says, you are a domain checker for a movie information agent. The movie agent can help with any movie related queries, including these are the set of questions that movie agent is designed to answer. But user is not constrained to it. He can ask any questions that can fall outside the domain. And here are the examples of invalid queries, which are the queries that fall outside the domain. Like, what's the weather today? How do I cook pasta? And such questions. Here I'm passing the user message, and also I will be needing output of that prompt, and here is the output format that respond with only yes if it's outside the domain or no if it's within the domain. So when I'm calling this particular guardrail prompt by passing this user message, what we get is a response. And here I'm checking if the LLM has responded with yes, that means it's outside the domain. So what I'm doing here is I'm creating a LLM response with a static text that says, I can only help with movie related queries. Please ask me about movies, genre, ratings, or movie information. So when this callback is called, it will check for the response. If the agent gets this response, then agent will not be triggered because this is something outside the domain. But if it is something inside the domain, then this LLM will be responding with no. And what I'm doing here is I'm returning none. And the agent thinks that as the callback has returned me none, then it will execute the agent. Let me show you this in action. And let me first fetch me top rated movies. So for this also one tool was there. Let me show you that as well. In agent.py, if you go, there is get top rated movies. So it called it and it fetched me top rated movies from the movies list that we had in one of the file. And let me ask something that's outside the domain, like what's the weather today? And as you can see, we have a static response and movie agent is not doing its job anymore. Now, in order to show you the logs that we had added for each of the functions, let me execute the same query again. And as you can see, let me also open the chart for you. In the events, yes, trace. Here it is. So when we are invoking the agent, so first comes before agent callback, right? And you can see here as well. First is before agent callback. Then there is one LLM call. So before model callback. So here it is before model callback. Now model is selected a tool. So it will be after model callback. Tool is being executed. So we will have before and after. So before and after. Then there is one more model callback because one more LLM that will do some polishing to the tool output. So we have before model callback and after model callback. And once this is finished, basically agent has completed its execution. And at last we have after agent callback. So most of you might have worked in applications, building software applications. So in any application you take, there can be many features in the application. And I just wanted to ask whether all these features you code in one file or you structurize your code. Yeah, you modularize, correct. So that's what happens in agent. Now, as you saw in Book My Show example, we are going to build 3 features. One will be regarding to movie, showtime, and seat. Now, all of this can be done by one agent. You can attach 7 to 8 tools to one agent, construct a pretty deep prompt, but it will be not accurate, as more the information you pass to the prompt, the more it will be confusing for the agent. So that's where handoffs kick in. Handoffs is a way of passing the task from one agent to the other agent. How it does is, let's say there is root agent. So in our case, that will be movie agent. So the prompt that you give to the movie agent is also sometimes called decision prompt. Here, what happens is, when the user query is received by the root agent, it will first do intent detection, what actually user is trying to achieve. And then it will check all the sub agents or all the child agents that a movie agent has, and it will check which agent can do this task for me. There can be 3 to 4 agents, but I know that this showtime agent is best suited for showtime related queries. Seat agent is best suited for seat related queries. So the agent is selected. So root agent will select that agent A can do my job. So it will hand off the task to agent A. Then agent A will do the actual task execution, and it will return the response to the user. So for that, we have part 4 handoff.
We'll take at the end.
You can just note them down, so we will come back. So we have movie agent, and only one extra parameter that we have added is sub agents, and only one agent that I have created for this part is showtime agent that you can find here. So for showtime also, we have all these 5 things, and extra 3 tools are being passed over here. And in movie agent tool.py, you have already saw this movie list, right? So in showtime also, what we are doing first of all is, we are importing that movie list from the parent file and then creating a showtimes list, which tells me nothing, that this particular movie is being running in these 3 shows. And for each shows, we have location, theater, showtime, and seat prices. And for that also, as you know, only tool attachment will not work. For in the prompt also, you have to say that when actually the agent has to call that particular tool. And also, as you have to mention tools, same goes for handoffs. Only this thing will not suffice. You also have to mention in the movie agent prompt actually when to call this showtime agent. So if you look over the prompt, after the tool section, there is handoff rules, which tells me that if the user asks about showtimes, locations, or theaters, hand off to the showtime agent. So thereby, root agent now knows that if user enters related queries to showtimes, then showtime agent is the agent to go. For this also, I can show you the demo. So let me first of all enter a query that falls into the movie agent domain. So there will be no handoff. It's the same response that we got in the last part. And let me say which shows are running in Delhi. Sorry, there is no data for Gujarat. So you can say that the movie agent has transferred that particular query to the showtime agent. So if you go over here, movie agent was the author that transferred the query to showtime agent. Then showtime agent made a tool call of get showtimes by location. Okay, showtime is Siri, I guess. Yeah, so for get showtimes by location, you can see that the parameter that was passed was location is equal to Delhi. And whatever response that we got from that dummy list that we saw in the file, we are getting over here. And I can also show you the trace for it. Yeah, so you can see I called the movie agent. Then there was it transferred that particular query to the showtime agent. Showtime agent selected the tool got executed, and the final response we got from the agent. Nice. Next, we have the final version. So this will be our architecture diagram. So in Google ADK, part 5 of Book My Show, we will be having 3 agents. One will be the movie agent, then showtime agent, and seat agent. Each are having access to different number of tools that it will need to fetch data. And there will be 2 handoffs. So movie agent will see whether the showtime queries, whether user is asking about showtime queries, then it will hand off to showtime agent. And if it is seat related queries, then it goes to seat agent. And now no more local list, we will go to the database. So for this part, so this is the Supabase portal and this is our database. Let me go it by one by one. So one of the table is movie table. So I have primary key, then title, genre, rating, just 3 fields. Then comes the showtime table where I have primary key, then the foreign key, movie ID. So for which movie is this particular record for? And I have on in which theater, in which location, at what time, and what are the category price. And at last I have seat table wherein I have primary key, the showtime ID, then the seat number, for which category is this seat included in, and whether the seat is booked or not. So a boolean true or false. You can also go through the dummy data that we have over here. So this is the movie table where I have title, genre, rating, and yeah, these 3 things. I also have showtime table where I have the ID, for me, which movie is this show, then goes theater, and that theater is located where, at what time, and these are the prices. So for gold, it's 265, for silver, 168, and for platinum, 435. And similarly, the last table that we have in this database is the seat table where I have the number for which category. So A4 belongs to a gold category. Is this seat booked or not? And which show is this seat related to? Cool. Now let's go to the last part of this agent, of this Book My Show example. So where I have movie agent, and along with showtime agent, I have also passed seat agent because we will be having 3 agents in this framework. Let me iterate through the seat agent. So for this, I have name, model, instruction, description, and also the tools over here. Yeah, for this tool. So we are not having a local list anymore. So we will be using the Supabase library that we had in requirements.txt. So it's pretty simple. You can just import create client from this library and just pass 2 parameters from the .env file. One will be the URL and another will be the API key. So here is one such tool that is used by seat agent that get available seats for showtime, and it passes these 4 parameters to it and it does the job for you. It will query the database by this all the user input, and it will fetch the data for you and pass it to the prompt. Now it has access to 4 tools. Out of this, 3 tools are doing a read operation. So it will just query the database and cache data. It will do not update it. There is only one tool over here, which is booksit, and that is related to update query. So whenever I say that book A4 for me, then it will go to the database and is booked will be marked as true. So I have to do the update operation that I am doing over here. That update is booked equal to true. And for all these 2 agents, I have also updated the handoff rules over here, which tells me that if the user asks about showtimes, locations, or theaters, hand off to the showtime agent. And if it is related to seat availability, prices, or booking, then hand off to the seat agent. Let me run this demo. Fetch me top rated movies. Then it made a tool call of get top rated movies. And this tool actually queries the database that we have on Supabase and it fetches the top rated movies. Now let me ask for where is Hera Ferry running in Delhi. So it transferred the query from the movie agent to the showtime agent, and it made a tool call and it told me that Hera Ferry is playing at Look Cinemas in Delhi. What are the showtime for Hera Ferry in Delhi? Look Cinemas. So it told me that it is running in Delhi at 8:45 p.m. And just to check whether the information is legit or not, let me move over to the database here in Supabase. So let's say for Hera Ferry, the ID is 13. Now what I will do is I will go to Showtime, and I already applied that filter 13. So I get the showtimes for that movie. Oh, I accidentally removed it. Just a second. Reload it. Yeah, again, no worries. ID. Let me go to movie ID and 13, apply filter. So these are the 6 to 7 show times that I have got, and there are in Delhi, Bangalore, Chennai, and Hyderabad. And in Delhi, as you can see, there is only one show at Lux Cinemas, and that also it is at 8:45 p.m. Right? So whatever data I am getting over here is actually coming from that database. Now let's book seats, and for booking the seats, let's pick this 8:45 p.m. and the ID of this is 4:49. So let me move over to seats section, and already I have passed 4:49, and we will be booking the seats that are available to me, and so that's why one filter is added that is booked should be false. So in this, you can see over here that there are 36 records available, right? Now let's say I will book C1 and C2. Book C1 and C2 for me in Lux Cinemas, 8:45 p.m. Delhi. So as you can see here, a Showtime agent transferred it to the seat agent, and it will call the book seat 2 times because I want to book 2 seats. And once it's done, it says that has been successfully booked for you at Lux Cinemas for 8:45 p.m. Enjoy the show of Hera Fairy. And you saw that it was 36 available seats. Now it should be dropped down by 2, so it's 34, right? Just to check over, it's 34. So 2 of the seats are already booked for you. Now, one question many of you will be asking is that why did Showtime agent transfer to the seat agent? If you see that Showtime agent and seat agent are not directly connected, they are connected by the movie agent. And in Showtime agent, if you see, let me move to your code, back to the code base. It does not have any sub agent. Seat agent is not here. Then why did it orchestrate it to seat agent? So remember in the first slide, I said that there is one description parameter, and the beauty of it will be evident in this version. What happens is any agent you pick, let's say movie agent. Now for movie agent, you have added 2 sub agents. One is seat agent and one is Showtime agent. And in prompt also you have said that if it is Showtime related queries, then go to Showtime agent. Otherwise, go to seat agent. But for Showtime agent, there is nothing mentioned about seat. Then why did it go to seat agent? If you see, for every agent, we have a short description. So what any agent in the ADK framework will do is, first of all, it will look over the prompt, whether it is finding something or not. If it is not, then it will look through the description of all the agents. And by looking at the seat agent's description, provide seat information based on the showtime and category. From this, the showtime agent came to know, okay, I don't know anywhere in my prompt in what agent do I orchestrate to, but I can see in my environment that there is one agent that does this for me. So showtime agent orchestrated to seat agent. So this marks an end of LLM agent section, and next comes workflow agents. So in LLM agents, if you see, the whole execution itself was very undeterministic. There was nothing specific that after this agent will execute, after this, the next in the pipeline. So if you want something workflow based, that you know that it should be deterministic and you know the flow. After this agent, call this, call this, call this. So it's where workflow agents came in. And there are 3 types of workflow agents. To start with, we will go with sequential agents. So it's a workflow agents that executes all its sub agents in a sequencing manner. So, and what happens here is, first the user query comes, this agent gets executed. It will throw the output the next agent in the line, and it will continue till the pipeline finishes. And here is one sweet example about it. So let's say you want to build an agent that can summarize any web page using only 2 tools. One is the get page contents, and second is to summarize the page. Now, this, if you see that there can be sequence agents, right? So first of all, you can fetch the page contents and then summarize it. So this is the example of sequential agents. And the other way around cannot work, because summarize can only exist if there is content. So first you can fetch the page content and then do the summarization. Second comes loop agents. As you would guess, it is something related to loop. And to explain it, we have one example here of math problem solver. Now, if you look over this diagram, what you will see is there is a sequence. Let me show you. This is the one agent, reasoner agent, and this loop is in sequence with it. So first this will execute and then the loop will carry out. So there is sequential manner. What reasoner agent does is when a user asks about a math problem, any fraction, algebra, any related problem, now reasoner agent's prompt is designed in such a way that it makes mistakes. And intentionally it's written in such a way that it has to make mistakes and never answer it correctly in one go. So whatever attempt the reasoner agent makes, that attempt falls into the loop. So whatever attempt reasoner agent is made will go in verifier agent. And in the loop, you have two agents, verifier agent and fixer agent. Verifier agent will make verification about what actually the attempt was, what was the user query, and is it correct or not. And there are certain evaluation metrics that we have wrote in its prompt, and it does the task for you. Whatever verdict that verifier agent gives to you, that verdict goes to fixer agent. Now fixer agent has access to both of the variables, the old output and the verdict. So it looks into the old output, it will verify that wherever he has gone wrong, it will try to fix it. Once this is completed, there are two break conditions in the loop. If it's a loop, there also has to be break conditions about when the loop should exit it. So there are two conditions over here. One is whether if the solution is correct, then I no more have to continue with the verifier agent, I can just exit the loop. If it is correct, then why to continue with the loop, just exit it. And second is max iterations over here. So for every loop agent, you can specify max iterations. If I say that let's keep it 3, then what it means is it will try to fix the solution 3 times. If it fails, then it's over. There is no more one extra loop. So if it is finished, then the loop is exited and the final solution has been given to the user. So for this, yeah. Guess it will not be visible. So here, as you can see, there's a sequential agent. As I told you that there is reasoner agent in sequence and then there is loop agent. So first we have a reasoner agent and then the math loop. It's a sequential agent that is imported from the same library from where the LLM agents was imported. Then comes a reasoner agent. These 4 things you already know about what that means. But here is one extra parameter called output key. So whatever output that this reasoner agent has, I have to store in it some variable because I have to then pass it to verifier agent. So for that, I have specified output key attempt. What this means is that when this agent finishes its execution, then the output will be stored in attempt key. Then here is the loop agent that we have the next in the sequence after the reasoner agent. Here you can see the name, the sub agents. There were only 2 agents in the loop. And then there is one extra parameter, max iterations, which is 5 for now. And you can look over to verifier agent. So the same structure as reasoner agent, there is just one change. The output key is now verdict. So if I go to the prompt, it gets access to the attempt that it has to verify. You can see over here, because we had mentioned output key equal to attempt in reasoner agent. And here is some evaluation criteria that verifier agent needs to take into consideration in order to evaluate whether the attempt is correct or not. And similarly, the last one in the line is fixer agent. So output key remains the same as attempt, because for every loop that goes in, we have to change the same attempt key, because that's the attempt key for that will taken into consideration by the verifier agent. And I missed to show you one thing, that in verifier, I have added one last line. If the attempt logic matches with your correct solution, then return correct as a string, as return not correct. Now what fixer agent does is, if the verifier's verdict is exactly correct, then do nothing, call one tool that I will show you just after this prompt. Call this loop and don't return any other text, then loop exited. And here, by the way, I'm getting access to both. What was my previous attempt? What was the verdict by the verifier agent? And in this agent, you can see there is one exit loop tool that I was talking about in the prompt of fixer agent. What this tool does is pretty simple. It's just a plain Python function, and it tells me that tool context.actions.escalate equal to true, and it returns me the string loop exited. So this particular line that you see over here, that escalate equal to true, this basically breaks the loop condition, and whatever solution that fixer agent gives at the last will be given back to the user. And to run it, I will be running it in separate port. Yeah, and for this, I need some pretty difficult example because 1 + 1 will not work. Yeah, so I have one example over here. A pizza is cut into 8 slices, and yeah. So you will see here, first of all, a reasoner agent will do its stuff, and that gave me a pretty bad answer because it's structured in such a way. Then the loop started. So we have the verifier agent that verified that it is not correct. In what all places did the user go wrong? Did the agent go wrong? Sorry. And after this is done, there comes the fixer agent, because in the loop there are only two agents, verifier and then fixer. So fixer try to fix it. Verifier again analyzed it, and again it was trying to fix it. And if it is correct, then you can see that exit loop tool call was done, and you can see the loop has been exited. And if I show you the traceability over here, you can see that I invoked the sequential pipeline. First comes the reasoner agent, and then you can see the loop agent is being in place. And in loop, you can see that there is verifier, then comes the fixer, then verifier, then fixer, and it will continue till the solution was correct. So at the end, you can see that fixer agent calls the exit tool and the loop is being exited. So out of the two break conditions, this was one of the conditions where the output was correct. But let me show you the another one when the max iterations limit is breached. And for the sake of example, what I will do is I will just do it as 1 and rerun the server. For every change you do, you have to rerun your server. It's not a auto reload type of thing. Let me copy the same example, reload it. Yeah, let me do this thing. So it will only go till one iteration, and that will be the limit. So reasoner, then one loop fixer, verifier, and then comes the fixer. And the loop is been exited. So it tried for one loop, whether you give the correct answer or not. Even if it is incorrect, the loop will be exited. And you can see here in traceability section also that only there is one loop. So verifier, then fixer, and it's finished. So yeah, guys, that was all from my side. And I will hand it over to Krunal for continuing with the remaining part of the presentation. Thank you.
Thank you, Soumya. Thank you so much. Am I audible at the back? Thank you, guys. Thank you so much. Am I audible at the back? Okay, cool. So we have seen the sequential agent, we have seen the loop agent, and now we are gonna deep dive into the parallel agents. So parallel agent is something that you use when you want to execute your sub agents in parallel. Those are independent of each other, and eventually you will also need one sequential agent, because when your agents runs in parallel, you will have to combine the output of your sub agents. So one classic example that we can see here is that if you want to implement a trip planner agent, so you will basically run the flights and hotel agent in parallel, and they will be independent operations, so you can execute them in parallel and then combine the results. So in the similar line, we are going to implement this trip planner agent. So over here, the use case is going to search the flights and the hotels and then prepare the day-wise detailed itinerary for the user. And it will run the flights and hotel agent in parallel. And once those two agents are done, their execution, we will combine the output. And based on that, we'll generate the detailed itinerary from that. So this is the architecture diagram. So the request will first go to the trip planner agent, and then trip planner agent will first call the parallel agent. It will gonna then ask the flight and hotel agent. They are gonna run in the parallel. And once we get the output of flight and hotel agent, that will be inside this flight results and hotel result. that will be passed to the itinerary generator agent. And we'll now take a look into the code. Just a minute. Is it big enough at the back? Now? Okay, cool. So over here we have this trip planner agent, which is a sequential agent. And here we can see that there are two sub-agents. One is parallel search and the another is itinerary generator. And this parallel search agent is running the flight agent and the hotel agent in parallel. There are two sub-agents for the parallel agent. We'll quickly take a look into the flight agent. So in the flight agent, we are using the Claude Sonnet 4.5, which is a different large language model compared to Gemini. And over here, we have given the instruction that you are a flight search agent. This is the current date. What you should do is you should call the search flights with the given parameters. And then you should format the result in the markdown. And we have also given the output format defined in the markdown. And at the end, we have these two things. One is the search flight, and another is the flight result. Flight result is the output key in which it will be storing the result and passing it to the itinerary generator agent. So in this search flight, it's a function that we are calling the SERP API over here to retrieve the current flight information. And if it is a one-way flight, then it will just call the flight from the one destination to the other, and it will just format the result and return the response. But if it is a round trip, then it will first find the outbound flight. It will also gonna find the return flight, and then it will format the results. So over here, we are doing anything complex, just calling the SERP API with the Google Flights, and we are just passing all the information, arrival, departure, the currency of the rate, and then whatever result that we get, we just do the bit of formatting over here. So since this API gives a comprehensive results, we are doing a bit of processing on top of it. This is nothing but just retrieving the required information and formatting it in a way that the user can easily understand. So once this flight agent completes its execution, the hotel agent is gonna also run in the parallel. And here we are using the Gemini 3 Pro preview as an LLM. And this is similar to how we have seen the flight agent. There is instruction that what is the current date, and your job is to immediately search the hotels with the given dates and destination. And similar to flight agent, we also have one tool available for this agent that it's gonna call with the given parameters. And same, it has also the output key that whatever information it is gonna find, it is will gonna store in this hotel result and pass it to the itinerary generator agent. In the search hotel as well, we are calling this SERP API, and we are here using the Google Hotels engine to retrieve the current hotel for the destination. We are gonna pass on this check-in date, check-out date, the number of adults, the number of rooms that we need, and whatever result that we get, we are gonna format it in the given designed format. So once these two agents completes their execution, the parallel agent is gonna then pass on the control to this trip workflow agent, and then trip workflow agent is gonna call the itinerary generator agent. So here inside this itinerary generator agent, we are using the GPT 5.1, another different LLM over here. And here we are mentioning that you are an expert trip itinerary generator agent with the global destination knowledge. What is the current date? And here we are mentioning that you have access to the following data. These are already shown to the user in the markdown format. And you have this flight result, search result. Your task is to extract the key information from the formatted result, find the cheapest flight, find the highest rated hotel, and then generate a complete itinerary. And for that also we have given how the format should look like. We have mentioned the output format in the markdown over here. And there are no tools because this is complete an LLM call. The LLM is going to generate the device itinerary. Now we will see this in action. Okay. I'm just gonna plan a trip from Mumbai to Singapore between uh, 10th to 15th Jan 2026 for 2 people. So, sorry, the date was wrong. But anyway, it understood my instruction. So it's gonna call the search flight tool, and it's also gonna call the search hotel tool. And this tool will be running in the parallel. We'll quickly see them in the traces that how they are running. And whatever responses they will generate, we will present that responses to the user. Like here we can see that this is the output of the flight search tool. It has given a few options to us to fly from one destination to the other. And it has also given the return flight options to us. And similar fashion, we will also have the hotel options for the Singapore, where there are different hotels that it has identified. We can see the price, the rating, the area where the hotel is. And then once we have this two set of information, the itinerary generator agent is gonna generate the day-wise itinerary. Since it's gonna do a lot of things, it will take a bit of time, but I think yeah, it has done its job. So here is the trip summary. We are going from Mumbai to Singapore and coming back to Mumbai. These are our dates. The duration is 5 nights and it is for 2 adults. So it has selected the cheapest flights over here, the Indigo, and it has also selected the return flight based on the information that it has available. And it has also found this cheapest possible combo. It has also given few options for us. This is a high budget option, and this is a balanced budget option to us. And then it has calculated the estimated cost, that how much it's gonna cost us if we want to choose one with the one option and the other option. And then we have a day-wise itinerary, like you will be arriving in the Singapore in the morning, and then in the afternoon you can go to the hotel, check in, freshen up, and in the evening you can go for the dinner. For the day 2, you can target the Marina Bay, Singapore River, sightseeing and culture. These are all live information that you can see over here. It has planned your day in the morning, afternoon, and the evening part. And this planning has been done for the entire 5 days. What a user can do in all those individual days. And then there are some tips from the agent that what you can do. These are the visa. This is the weather information. The currency is Singapore Singapore dollar, and the local transport options also it has provided. And the connectivity information is also given. So this is how the itinerary generator agent leverages the parallel agent, sequential agent, and generate the final itinerary for the user. So this is the one example where we can see the both parallel and sequential agent in action together. Okay, so now we are gonna do a deep dive into the memory part of the Google ADK. So this is the memory architecture of Google ADK. These are the individual sessions that the user interact with the agent, and the events are nothing but the chats, the interactions that a user does with the agent. And you have different sessions available. Each session has its own state, and all this information is fed into the global context. So the flow usually looks like that whenever user does any query, it will refer to the current state. It will also get some information from the global memory, and it will also find the relevant past session state. And it is going to combine them all together and then pass it to the model for the getting the answer. And once model responses, once the session is done, it is going then again going to update the global context. So this is how the memory portion works in Google ADK, and we will also leverage this in our upcoming example. So the next example is about custom agents. So we have seen a fully autonomous agent, we have seen the workflow agents, but if you want to, if you want more control on the memory, if you want more control on the tool execution and handoff, that's where the custom agent signs. So all you have to do is just import and inherit this base agent from the Google ADK agents, and you have to implement this run async IMPL asynchronous method. So we will see both memory and this custom agent in action. So we'll go through one example, recipe recommendation example. So it is going to remember user preference. And based on that, it will also route the request to the memory agent, or it will also route the request to the recipe recommendation agent. Let me also show you the architecture diagram. So this is how it's gonna work. A user will ask a question. There will be a recipe orchestrator custom agent. And based on the query type, if it is a preference query, then it will redirect it to the root agent. If it is a recipe query, then it will go for the recipe search agent. And they both eventually also interact with the memory store. Let me give walkthrough as well. Okay, so here we have a recipe orchestrator agent, and as you can see that we are importing this Google ADK agents base agent, and we are inheriting it over here. This is a very simple logic which can be also done with prompt engineering, but just to help you understand how custom agent works, we have written this logic over here. So there is a very naive search written that it will identify whether the given query from the user is a memory query or is it a recipe search query. And if it is a memory query, then it is gonna redirect it to the memory agent, and if it is a recipe query, then it is gonna redirect it to the recipe search agent. So all this logic is written over here inside this run async IMPL asynchronous method. Let me do one thing. Let me clear out my preferences. Okay. So now if we look into the memory agent, so here we have used again a different LLM, Claude Haiku 4.5. And the job of this memory agent is very simple. Your task is to help users set their preferences and manage the recipe ratings. So it has bunch of tool available. It has dietary restriction tool. It has a tool to add the favorite cuisine. It has a tool to add any disliked ingredients. And there are also tools available to retrieve the user preferences, rate the recipe, and get the recipe history. So there are bunch of tools available here. What we are doing to manage the memory is we are storing everything inside a JSON file. You can also integrate a real-time database over here and manage the preferences per user. But for the sake of simplicity, we are doing everything inside a JSON file. So we have one user preference dot JSON defined here, where we are gonna store the dietary restriction, favorite cuisine, or any ingredients that the user doesn't like. This can be again a database call. So we have this memory store function, and we are just calling this loading the memory. This memory is being loaded through JSON file over here. We can see that this is the memory file, user preference.json, and it is gonna load everything from that JSON file into the memory. So all this information like adding preferences or adding the say favorite cuisine or anything that a user doesn't like, we are gonna store everything into the JSON. So that's the job of memory agent. We also have the recipe search agent, and here we are using again GPT 5.1. And the goal of this recipe search agent is that we are gonna define the persona over here, that it's a knowledgeable recipe assistant, and we are mentioning the today's date. And this is the workflow that first check the user preferences, call this to load dietary restriction, favorite cuisine, and then based on the user's request, it is gonna generate the recipe recommendation over here. And here also we are mentioning that respect user preferences automatically and handle all different search types. And here we have this tool. So this tool will be called every time when we we ask a question to the agent, and it's gonna remember our preferences. So let's see this also into action. I'm just asking like what are my preferences, and it will gonna find my preferences, and then it will say that okay, it looks like you haven't set anything. This is what it found from the system. Now I'll tell that I am a vegetarian. Uh, I love Gujarati food and hate milk. These are not my actual preferences, but just for the sake of example, I'm showing this to you. So here we can see that there are a bunch of tools called like dietary restriction, favorite cuisine, and dislike ingredients. We are calling this tool and saving the preferences. Then now if I ask again like what are my preferences, so it will honor them and it will show that okay, these are my preferences. And now I will ask that okay, find me some recipe for breakfast. So what this tool will do, this agent will do, it will gonna first call the get user preferences tool. It will find all the preferences that I have already set in the system, and then it will do the uh, breakfast search recipe for me, and it will honor the choices that I have already configured. This usually takes some time, but yeah, again, this is fast enough. So here, as you can see, like here are some vegetarian Gujarati style breakfast ideas, and I'll keep them milk free, but may use yogurt or curd only where that can't be swept. So you can see over here, like it has given me the option of vegetable upma. These are the ingredients, and these are the steps that you can implement. Then there are patata poha, again a Gujarati style dish, and then thepla, again Gujarati preferences. Handwo is also Gujarati preferences. Then again quick besan chilla. All these are Gujarati preferences. So we can also see the events over here, like so there are a bunch of events. Whenever we ask like, okay, what are my preferences, it's gonna call these tools. And when we asked about adding the preferences, then it called this add dietary restriction, add favorite cuisine, add dislike ingredients tool. It inserted all the information, and then we asked about recipe of the breakfast. It first find the preferences, and then it generated the recipe. We can also see the traces here. Yeah, so first it found the preferences from this get user preferences, and then this LLM call took 20 seconds to respond with the recipe information. So this is how you can implement a custom agent, and this is also how you can leverage the memory information, and you can combine the two. You can do any sort of customization over here. You can also incorporate sequential and parallel agent inside the custom agents as well. So in a summary, we have seen different types of agent. If you want full autonomy, you want your agent to do everything without any intervention, so you can go for the LLM agents. If you want a bit of predictability along with the autonomous, so you can either opt for the sequential agent when there is a dependency between the sub agents. If you want your agents to run in parallel, then you can use parallel agents. If you have a use case of loop agent, then you can also implement them. And if you want the full control, you want to do the mix and match of all these types of agents, then you can opt for the custom agent. And then there is this last multi-agent system. So that is a very complex example. So let's say if you want to build an AI startup where you want to productionize any vague requirements and implement everything, all the features. So that for that you can leverage this multi-agent system. In the multi-agent system, you can define that there will be different individual expert agent available for your disposal. There will be product manager that will be taking the requirement from the user. There will be an orchestration manager that will be driving the entire project from the product perspective, from the delivery perspective as well. You will also have a tech lead, which will be like responsible for designing the architecture diagram. Then you will also have product team that will create Jira stories, developers working on the Jira stories. You will have QAs validating the output of the implementation. And then you will also have an agent that will be generating the invoices of all this work. So when you want to implement something of that complex, like AI startup, that's where you can leverage the multi-agent system. It's nothing but you mix and match all these different combinations that are available for your disposal. So with that being said, we are done with today's session. Thank you so much for joining me.
Thank you.